first example, this should have been probably the easiest one. Doesn't mean it's easy, but it definitely got harder after this one. So h prime of x, remember from yesterday, you're thinking, okay, what is the shell? In this case, the shell is the cube. The chocolate is the inside, or you could say outer and inner function. So the 3 gets multiplied to the front like power rule. Then you have x squared plus 5x minus 8 to the 2 power times 2x plus 5. And that is the derivative on question 1. Okay, question 2, you had to know what the derivative of tangent is. What is it?
Secant squared.
I love it. So h prime of x equals secant squared. Keep the 3x though. Then times 3. Okay? Take the derivative of the outside part, keep the inside part the same, times derivative of the inside part. All right, looking at number 3, first of all, we got to kind of break this down. The 3x squared, I'm going to put that in a little set of parentheses. Is this saying cosine times sine?
No.
Cosine of sine. So this is also 1, although I'm going to have to use chain rule to do that when I get to that derivative. So for this, h prime of x, first thing is derivative of 3x squared. That's 6x. Then just write the second. I'm using product rule, by the way. Plus, then you're going to just write 3x squared. Then you're going to, this is where we're going to have to use chain rule to take the derivative of cosine of sine x. So the derivative of cosine is negative sine. Keep sine x the same. Then times the derivative of sine x, which is cosine x. All right. So that is the answer to 3. Okay. Number 4. I'm gonna do this one down here. We're gonna have to use quotient rule. So I'm going to write a big, long fraction bar, and I'm going to go ahead and write 2x plus 1 squared in the denominator. On the last test, a lot of you, that's what you forgot to do. Okay, not a lot, but more than a few people. Okay, so in taking the derivative of the top, this is where I'm going to need to use chain rule. So 3, 2x plus 2, cut the power down by 1, times the derivative of the inside, which is 2. All of that is just the derivative of the top. So remember in quotient rule, you do derivative of the top times the bottom, 2x plus 1, minus the top, just regular top, I'm running out of room, times the derivative of the bottom times 2. Barely fit it in there. All right.
Why did you do minus 2x plus 2?
So in quotient rule, you have the derivative of the top times the bottom minus the top times derivative of the bottom. Okay, all over the denominator squared.
Where did the
So the times 2 came from the derivative of the denominator.
Okay.
Yeah. So the hard part about this is like keeping, you know, it's the big picture. Each individual thing is easy, but keeping the big picture, that can be kind of difficult. All right, so that was kind of a review of what we did yesterday, just kind of different types of problems from the easy ones to the hard ones. And what we're going to do now has to do with function within a function within a function. So thinking of an M&M, okay, that's a function within a function. But when we get to a peanut M&M, all right, we have a shell, we have a chocolate, and we have a peanut. Okay, the shell's still the outer function, but now the peanut is the most inner function, and chocolate's kind of like, it's the outer of one and the inner of the other. Okay, so we'll just say it's like the middle function, okay? So, excuse me, so look at number 5. I'm going to talk about this a lot today, but let me remind you, when you see a squared in between the sign and the 2x, that means the whole sign and the argument is being squared. That's the notation that you used last year. We're using the same notation now. But it helps me a lot more if I write it this way. So next time, like if we just skip down here to 7D, you're going to have to know, hey, that squared means cosine and 3x. The whole thing is being squared, okay? So this right here is easier to, we want to use it in the second way I've written it. Okay, so here's what I want you to do. We're going to eat the peanut M&M while we do this problem. So again, I want you to put the peanut M&M in your mouth, but I do not want you to crunch down on it. All right. So watch this. This is going to be really easy if you can follow these steps. So the shell, okay, what's the shell of this problem? 2. Remember, the whole thing is being squared. The whole thing is being squared. So the 2 is the shell. So I'm going to melt the shell, and I'm going to keep everything on the inside the same. So the 2 gets multiplied to the front. We keep sine of 2x the same. Subtract 1 from the power. That gives you 1. You don't have to write the 1, obviously. And that's the shell melting. All right. Next thing. Okay, which one would you say is middle, but definitely not the innermost one? The sine. That's the chocolate. And in my mouth, I'm starting to taste the chocolate. The shell's pretty much melted, and I can taste the chocolate. So I'm going to multiply by the derivative of the chocolate. What's the derivative of the chocolate? Cosine. And keep the peanut. I don't even taste the peanut yet. So keep the peanut. Don't take the derivative of it yet. So derivative of sine is cosine. Keep the 2x the 2x. Okay, this last part is going to require you to have some self-control. I want you to keep the peanut intact in your mouth. Don't crunch it, but you can suck and dissolve all the chocolate away. But don't eat the peanut. So right now, it's kind of weird. You kind of have like a flavorless peanut in your mouth, right? And if you cheated, some of you cheated, I bet. All right. So remember, the peanut is the innermost thing. So the peanut is the 2x. So the last thing you're going to do, now you can crunch down on the peanut. That's us taking the derivative of the peanut. So what's the derivative of 2x? 2. All right, that is your answer right there.
Wait, so what's the first? So the sine squared 2x?
Yeah.
What was that?
So whenever the squared is right here, it doesn't mean you're squaring sine. I mean, you are, but you're squaring the whole thing.
Oh, so it's moving.
So it's better for you if you rewrite it. And we're going to practice this some more. Okay, I color-coded this one, but I'm not going to do that on every problem, okay? So let's look at number 6. This one's a little bit easier, I think, to tell what's the shell and the chocolate and the peanut. Okay, if you just go outside the N, sine is the shell, cosecant is the chocolate, and x squared is the peanut. So if you want to do this with another peanut M&M, do this. Okay, or you can just crunch down on your peanut M&M, but remember how we did it the first time, whatever you want. So h prime of x, first we are going to dissolve the shell. Okay, the derivative of sine is cosine. But the chocolate and the peanut, they stay the exact same for now. I did not leave myself enough room, so I'm going to rewrite this over here. Oh, that's a really big erase bubble. Okay. All right. Times. Okay, now the shell is gone. If you think this sign is going to throw you off, cross it off so that you know you took care of it. The shell is gone. Once you dissolve the shell, it's gone. Now we're going to dissolve the chocolate, keeping the peanut together. What's the derivative of cosecant?
Negative cosecant plus cotangent.
Negative cosecant, so I'm going to do negative cosecant x squared, cotangent x squared. Okay? Then, once you fully dissolve the chocolate and derive that, that's gone. Now I'm going to take the derivative of the peanut, which is 2x. And this is how we work these problems. Okay? So maybe yesterday the M&M helped you a little, but not a lot. The whole idea of a peanut M&M here, I promise you it makes this easier. Okay? All right, so the hardest part I find that students have is this idea of parentheses with trig. We already looked at it on one problem. So I'm going to kind of talk about the implied notation of trig and how you can rewrite it to make it easier for you. So looking at A here, cosine 3x squared. What's implied here is that you're taking cosine of everything after the cosine. Since there were no parentheses, it's implied that you're just, that whole 3x squared, everything you're taking cosine. So I have cosine of 3x squared. This is an M&M. Is it a regular or peanut M&M? It's regular. Regular because there's just two things, right? There's not three. So if there's just two things, we start with the outer one, derivative of cosine, that's negative sine. Keep the inside the same. Then we do times the derivative of the inside. Okay, that is how you do chain rule. But again, if you didn't understand the original problem, this could have been difficult. All right, for B, let's talk about this. This one today has been giving people problems. Okay, they do have parentheses on B. I mean, it's essentially the same thing, but with parentheses around the cosine and the 3. So what are you taking cosine of in this?
3.
Just the 3. You are not taking cosine of x squared. You're just taking cosine of 3, and then that's being multiplied to x squared. All right? Cosine of 3 is not a function. It's a number. Could you type in cosine 3 in your calculator and get a decimal? You should. So here we go. That's a number. All right? Now, before we write down our answer, let me just ask you. If I had y equals 5x squared, again, a number x squared, what would the derivative be? 10x. Would it be okay if I wrote this as 5 times 2x? Is that the same thing? Yeah, we just know to multiply the 5 and the 2. So, but with cosine 3, okay, I want to multiply that to the 2, but I don't know what cosine of 3 is. Like, I can't evaluate it. It's not an exact value. Okay, we'd need a calculator. So I am just going to write cosine of 3 again times 2x. Okay? The only reason I can do this is because cosine of 3 is a number, like 5. It's not 5, obviously, but it's a number like 5. So we had y equals 5x squared. All we're doing is the 5 gets multiplied to the 2x. We already have done that before. But intuitively, we always actually multiply those numbers in our head.
2x is one thing.
Yeah. I mean, they're just being multiplied to each other. Okay, let me just tell you, I have not used chain rule or product rule or anything. I just use basic power rule to do this. And this is weird because we don't typically see cosine of just a number. All right, so that is our answer. But I don't think that if I let you guys loose on your own, this is how you would have probably done this. Okay, so what I want to do is let's talk about how you would have done this. Okay, maybe you would have done product rule. Okay, cosine of 3, x squared. You might have done product rule. So look what happens when you do product rule. We'll just do this. Okay. You would have had y equals, what's the derivative of cosine of 3? Okay, so if you say negative sine of 3, you're applying chain rule. So then we have to go times the derivative of 3, which is 0. It's a lot quicker, again, if you say, hey, cosine of 3, that is a number. What is the derivative of a number? 0. So I'm just going to write 0 there. Okay. The derivative of any number
But
is
why did you
0.
put for y1 up there at cosine 3?
Because I didn't do product rule here.
Oh!
I'm just doing it a different way. And I'm going to show you that our answers are going to be the same. So if we do product rule and we do derivative of cosine 3, and then I write x squared, then I would go plus, then I would just write cosine 3, and then I would take the derivative of x squared, so which is 2x. So let me ask you, is what I've written here the same as what I wrote in blue, or equivalent? We'll just say equivalent. Yeah, because what's a 0 times x squared? 0. So you can over-apply product rule and still be fine. You can over-apply chain rule and still be fine. But the better you are at trig and algebra, the less work you have to do. So C is a perfect example of this. So looking at C, what's being squared on C? The 3 and the x. Is the cosine part being squared too?
No.
No. So, but you are taking cosine of all of it. So I'm going to put in extra parentheses here. And this makes it really clear. And I could do this as a peanut problem. And I'm going to go through this quickly. Then I'm going to show you an easier way to do this. If we do this as a peanut problem, we say, okay, I would start with cosine because it's the outermost function. That would be negative sine. Then I would just rewrite the inside part. I would go times. Then I would get to this. What's the chocolate in this problem? The squared. So then I would go 2 times 3x to the 1 power. Then you would get to the peanut, which is 3. Okay, this is totally fine for an answer. This is the correct answer. There's nothing wrong with this. However, look what happens, and I really am writing way too big here, by the way. Sorry about that. Look what happens when you do one simple algebra. Can I rewrite this part? How can I rewrite 3x squared? 9x squared like that, right? This is no longer a peanut M&M problem. I should have put prime over here, by the way. All right, derivative of cosine. What's the derivative of cosine? You keep the inside the same. Then what would you multiply by? 18x.
Would you have the second answer as an answer choice or something?
If we had this on a test and your answer was right, you would get the points. We're getting into problems where there is, on most problems, going to be more than one way to solve it. Generally, one way is easier than the other way, but I would never penalize you for doing it the hard way. The only problem is, what if it was multiple choice and all my answer choices were like worked out the easy way? But we're just learning this for now, so that doesn't need to be, we don't need to be concerned about it. What I'm asking you guys to do is just, instead of just saying, do the same thing every time, is to get into the thinking, if I can make the problem easier using algebra or trig, let's do that. Because this is the same thing, by the way. Like, let's compare them. Negative sign, 3x in parentheses squared, that's the same as 9x squared. 2 times 3x times 3, that's the same as 18x. Okay, I'm not showing you more than one way to confuse you. If you're like, that confuses me, then no, then you don't understand it to begin with. Okay, I want you guys to see that how you write this does depend on like how well you understand the algebra and the trig. Algebra and trig are way harder than calculus. Okay? And I understand that students don't remember everything they learned from Algebra 2 in their pre-cal teacher. So I'm trying to help fill in the gaps there. All right, for now, I am going to erase both of these red answers because I just want to have room on here, okay? And I don't want y'all, here's the other thing, I don't want you to be doing a problem and go, wait, I think it could be done this other way. Or is it done this way? Well, you're probably right. It probably could be done 2 different ways. Okay, look at D. D looks an awful lot like the first example that we did with this peanut M&M. What does this squared right here mean?
Everything's squared.
Everything is squared. So look how I rewrite this. I'm going to write it as cosine with a 3x in parentheses, because that's what I'm taking cosine of. And then the whole thing in parentheses is squared. If you don't rewrite it this way, you are going to get confused. This isn't just like at my preference. This is what I know is helpful for students or not helpful. So we have y prime. This is a peanut M&M problem, so I want you to try to do this one on your own. And if you need help, just look up at example 5. It's very similar. Even I do that sometimes. Okay, I want you to compare your answer with mine. So the shell here is 2, multiply 2 to the front, keep the inside the exact same. Subtract the power by 1. Then take the derivative of cosine, keep the 3x the same, then take the derivative of 3x. All right. If you're kind of not too good at still power rule or product rule, this stuff is going to seem a lot harder than it should to you. All right, so just keep in mind that you've got to practice. You have to do the homework. Nobody understands this just by watching me. Okay, we're going to skip you. All right, let's look at number 8. So on number 8, derivative of f of g of x. Okay, we got to unpack this. This is a M&M problem. Okay, f is the shell, and g of x is the chocolate. Okay, this would be a peanut M&M if it was like f of g of h of x. So first thing is we got to do the derivative. So I derive the shell, that's f prime. The chocolate, though, stays the exact same at the beginning. Then times the derivative of the chocolate. This is actually just the formula for chain rule. But I don't expect you to have that memorized. You can always figure it out this way. Okay, using the M&M, by using the M&M analogy, you should be able to always use the chain rule, even if you don't have the formula memorized. Okay, next we got to plug in the number. X equals -1. So that's going to go in both of the places you have an X. So let's rewrite the problem, but instead of X, we write -1. All right, the next thing we're going to do is actually solve these things. And we're going to do that by looking them up in the table. So look at the table, and I want you to find the intersection of x equals -1 in the g column. So here's g, here's x equals -1. So -2, that's that value right there. Okay, and we have an f prime in front of it, so I'll get to that in a minute. G prime of -1, well, here's G prime. Again, -1, that value is 3. So this is how you look up values on the table. You just find the intersection of the x that you want and the function that you want. All right, now we got to look up f prime of -2. So I'm looking in the f prime column, I'm looking in the -2 row, and that value is -1. So I have -1 times 3. The answer is -3. Any questions on that? Okay, I want you to try the next one on your own. Okay, the answer for number 9 is 3. Okay, I'm going to come around and help you guys if you were unable to get that.